another video in the chemical bonding discussion series. In this video, we will be discussing the valence shell electron pair repulsion theory, or the Vsepr theory, as well as the different molecular shapes. So to determine the molecular shape, we use the Lewis structures and then apply the following theory to convert the two-dimensional structure into a three-dimensional shape. And that theory is what we call the valence shell electron pair repulsion theory. According to this theory, to minimize repulsions, each group of electrons or each group of valence electrons around a central atom is located as far as possible from the others. When we say a group of electrons, it is any number of electrons that occupies a localized region around an atom. So a single electron group can be a single bond, a double bond, a triple bond, a lone pair of electron, or one lone electron. So only these electron groups around the central atom can affect the shape. However, the electrons on atoms other than the central atom do not affect the shape of the molecule. So we need to make a distinction between what we call the electron group arrangement and the molecular shape of a particular molecule. So when we say electron group arrangement, it is defined by the bonding groups of shared electron pairs and the non-bonding electron groups, which are the lone electron pairs around the central atom. While when we say molecular shape, this is defined by the relative position of the nuclei, which are connected by the bonding groups only. So when some are non-bonding groups, different molecular shapes occurs. So we will be talking about more of it later. Thus, the same electron group arrangement can give rise to different molecular shapes. Some are with all the bonding groups and others with bonding and non-bonding groups. So to classify the molecular shape, we assign a general formula to the different possible shapes, like this one. So the general formula would be Ax sub m E sub n, where here m and n are integers, and where A is the central atom, and then X will be the surrounding atom, and then E are non-bonding valence electron groups. So what are the different shapes of the molecules? So here are the different shapes of the molecules based on the Vsepr theory. The first one would be the linear arrangement or the linear shape, wherein they have here one central atom and then you have two atoms bonded to the central atom. So this, if we will go back to our general formula, it will give us the formula AX2. So this bonding angle is approximately 180 degrees to maximize the distance between the two electron groups. So these are the two electron groups attached to our central atom. The next shape is what we call the bent shape or the V shape. As you can see here, there is also one central atom and then there are two atoms bonded to our central atom. However, in the central atom, we have two lone pair of electrons. So if that's the case, our general formula would be A X2 and then E2, because you have two lone pair of electrons. So that will give us the bent or the V-shaped molecule. The next shape would be what we call the trigonal planar. So in trigonal planar arrangement, we have one central atom and then three atoms bonded to the central atom. So again, if we go back to our general formula, we will arrive at the general formula AX3 because there are no lone pair of electrons. The next shape would be the trigonal pyramidal, wherein there are also three atoms bonded to the central atom. However, in the central atom, we have one lone pair of electrons. If we go back to our general formula, we will have AX3E because you have one lone pair of electrons, and that will give us the trigonal pyramidal shape of the molecule. And then we have here the T-shaped, and then the square planar, and then the trigonal bipyramidal, and the octahedral. So you will be able to see most of these illustrations and this summary of the different types of formula for each ideal shape or the molecular shape of the atom. So you can see this on your book. So you will just need to identify how many shared electron pairs are there and how many unshared electron pairs are there in the central atom. Here are the steps that we can follow to determine the molecular shape or the molecular geometry. So we have here the first step, the molecular formula. Of course, you need this to draw the Lewis structures. And then once that we have drawn the Lewis structures, we can count all the electron groups around the central atom. And then we also have to note the position of any lone pairs and double bonds, as well as count the bonding and non-bonding electron groups separately. So when we have done these steps, we can now identify the molecular shape based on the general formula that we had, which is A x sub m E sub n, where again, m and n are integers, while A is the central atom, x would be the bonding atoms or the surrounding atoms, while E would be the lone pair of electrons. Now let's work on some examples. So we have to draw the molecular shape and predict the bond angles of the following compounds, PF3 and COCl2. So for the first compound, PF3, again based from our steps in determining the molecular shape, we have to identify or to write the Lewis structure from the formula. So if you remember our lecture or our previous video on Lewis structures, you have to arrive at this Lewis structure for PF3. So again, PF3, there are 26 valence electrons, and then the Lewis structure would look like this. So there are 4 electron groups around P. Again, you have here the lone pair, and then you have 3 surrounding atoms. Those are the electron groups. Now, if you look at this one, supposedly if we have 4 electron groups around the central atom, we can give it a tetrahedral shape. However, if you look at the central atom, it has 1 lone pair and 3 surrounding atoms. If that's the case, we look at another shape, which will be the trigonal pyramidal. Okay, so the trigonal pyramidal, you have 3 bonded atoms on the central atom and then 1 lone pair, and approximately the bonding angle would be less than 109.5. Again, you have to check your book for as a reference of these bonding angles. And then if we go back to our general formula, we have here AX3, since you have 3 bonding atoms here, and then you have E, you have 1 lone pair of electrons on the central atom. Another example would be the COCl2, where there are 24 valence electrons. Again, if you can remember our previous discussion on Lewis structures, you should arrive at this Lewis structure for COCl2. And then, we have to assign the electron group arrangement. So you have 2 single bonds and 1 double bond, which give 3 electron groups around the carbon atom and a trigonal planar arrangement. And now we have to predict the band angles. So the band angles or the ideal band angle in the trigonal planar arrangement is 120 degrees. But since the double bond between the carbon and oxygen will compress the bonds between carbon and chlorine, the angle should be approximately less than 120 degrees. And then we draw and name the molecular shape. So there are again 3 electron groups with no lone pairs on COCl2. Therefore, it is a trigonal planar arrangement. So this would be the shape of our molecule. And that's it for our video on the Vsepr Theory and molecular shape. Thank you for listening.